Hello friends, welcome to True Event Academy. In the last lecture, we have started the discussion on the generalized coordinates and degree of freedom. So in this particular lecture, we will discuss various examples on the generalized coordinates and degree of freedom. So let's start our discussion. So what we have seen in the previous lecture is that generalized coordinates are the independent coordinates that are required, that are sufficient to determine the position of particle at any time t. तो पार्टिकल की पोजीशन को डिटरमाइन करने के लिए जो कोऑर्डिनेट्स की जरूरत होती है उसको क्या बोलते हैं? जनरलाइज्ड कोऑर्डिनेट्स. ओके, सो द जनरलाइज्ड कोऑर्डिनेट्स आर द इंडिपेंडेंट कोऑर्डिनेट्स दैट आर सफिशिएंट टू डिटरमाइन द पोजीशन ऑफ पार्टिकल एट एनी टाइम t. ओके, or how we can find the generalized coordinates? Number of generalized coordinates. The number of generalized coordinate or degree of freedom, both are same. The number of generalized coordinate is equal to degree of freedom. So how we can find? In 2D plane it is 2 times of number of particles minus constraints, and in 3D plane it is 3n minus k, where n is the number of particles and k is the number of constraint. Okay, and what is the degree of freedom? So the number of independent ways in which the particle can have motion is known as degree of freedom. Okay, so what we have seen in the previous lecture, so let us suppose we have a curve like this. Okay, and let us suppose the position of particle is at point P at t is equal to t1, and it is at point Q at t is equal to t2. Okay, so let us suppose the coordinate of particle at point P is x1 y1, and at point Q it is x2 y2. Okay, so x1 and y1 is determining the position of particle at point P. x2 and y2 is determining the position of particle at point Q. Okay, so at random point R, let us suppose the coordinate is x and y. So the x and y is determining the position of particle at point R. So x and y are our generalized coordinate. Okay, and we have number of generalized coordinate is 2 here. Okay, so number of generalized coordinate is 2 here. Okay, और जितने जनरलाइज्ड कोऑर्डिनेट होता है उतना ही डिग्री ऑफ फ्रीडम होता है. सो द डिग्री ऑफ फ्रीडम विल बी डिग्री ऑफ फ्रीडम इज इक्वल टू 2 हियर. ओके, तो कितने तरीके से पार्टिकल की कोऑर्डिनेट चेंज हो रही है? तो एक्स में चेंज होने की वजह से हो रहा है और वाई के चेंज में होने से हो रहा है. ठीक है, तो एक्स में कैसे चेंज हो रहा है? x1 टू x2, और वाई में कैसे चेंज हो रहा है? y1 टू y2. कितने तरीके से पार्टिकल की कोऑर्डिनेट चेंज हो रही है? 2 तरीके से. तो डिग्री ऑफ फ्रीडम विल बी 2. So this we can seen in the previous set of lecture. Also we have seen that due to presence of constraint, the degree of freedom gets reduced by 1. Okay, so how we can show this? So let us take a circle. Okay, let us take a circle of radius a. Okay, this is circle of radius a. Okay, so we have the coordinate of particle as p, x and y. Okay, so what is the constraint here? So the position of the particle is restricted to move in this particular fashion, that is on a circle. So we have the constraint here is constraint on x and y is x square plus y square is equal to a square. So this is our constraint. So here k is equal to 1. Here. Okay, so we have the position of particle is p, x and y. How we can write y? So y is equal to a square minus x square and ka under root. So we have the coordinate as p x comma a square minus x square. Okay, so for determining the position at any point, so let us take this point as q. What we need? Only x value is required. Okay, suppose x is equal to 2. So what will be p? So this will be equal to 2 comma a square minus 2 square under root. Okay, so only we need x. So x is our generalized coordinate. X is equal to generalized coordinate. Okay, so this is the case in the case of a Cartesian coordinate. So let us discuss this in terms of polar coordinate. Okay, so we have the polar coordinate. So the any position can be represented as a comma theta. Okay, so only we need theta to determine the position of a particle. Okay, suppose theta is equal to 30 degree. Obviously we can determine the position of particle. Radius we already know, a is known to us. Okay, a is known to us. ये तो हमें पता है ना, सिर्फ थीटा बताने से हम पार्टिकल की पोजीशन को डिटरमाइन कर सकते हैं। सपोज थीटा इज इक्वल टू 30 डिग्री, व्हाट वी विल डू, we will take the angle as 30 degree. So obviously we can determine the position of particle. If theta is equal to 60 degree, obviously what we will do, we will take an angle at 60 degree. So this is our position because A is already known to us. Okay, so this will be A comma 30 degree and this is A comma 60 degree. So सिर्फ थीटा की वैल्यू बताने से हम पार्टिकल की पोजीशन को डिटरमाइन कर सकते हैं. That's why theta is our generalized coordinate. Generalized coordinate. So the number of generalized coordinate is 1. Number of generalized coordinate is equal to 1. We can write as GC for the short form of generalized. So number of generalized coordinate is 1. अब degree of freedom. Okay, so degree of freedom कैसे निकालोगे? तो the particle की position कितने तरीके से चेंज हो रही है, ठीक है. Let us take two examples. Okay, so this, let us take two particles. So this is and we have this is, let us take this as at angle of theta 1 and this point at an angle of theta 2. Okay, so the coordinate of this is A comma theta 1 and this is A comma theta 2, P and Q. So the position of particle got changed from P to Q. So position of particle got changed from P to Q. Okay, so the coordinate कैसे चेंज हुआ, A comma theta 1 से A comma theta 2. Okay, so A is fixed here. So सिर्फ यहाँ क्या हो रहा है, थीटा में सिर्फ चेंज हो रहा है ना, चेंज. तो थीटा में चेंज की वजह से पार्टिकल की पोजीशन चेंज हो रहा है. तो कितने तरीके से पार्टिकल की कोऑर्डिनेट चेंज हो रहा है, सिर्फ एक तरीके से. थीटा में चेंज की वजह से पार्टिकल की पोजीशन चेंज हो रही है. सपोज वी हैव द थीटा इज इक्वल टू थीटा 3. ओके, सो द पार्टिकल की पोजीशन यहाँ हो गया. ओके, सो ऑन चेंजिंग द थीटा from theta 1 to theta 2, theta 2 to theta 3, the position of particle is getting changed. So theta में change की वजह से particle की coordinate change हो रही है. So we have the degree of freedom as 1. Okay, and it is equal to number of generalized coordinate. Okay, as simple as that. So let us discuss questions. Okay, so we have a particle moving on circumference of a circle. Okay, we have to find generalized coordinates and degree of freedom. A particle moving on circumference of a circle. Okay, so let us take a circumference of a circle. So we have the coordinate axis like this. Okay, and we have the particle moving on circumference. So let us draw the circumference of a circle. Particle moving on circumference of a circle. So let us take a particle. So this is a circle. So let us take the radius as A. Okay, so let us take a random particle here. Okay, so this is A comma theta. Okay, so only theta is determining the position of particle. Okay, so let us take a particle at this point P. Okay, which is at an inclination of theta 1. This coordinate is A comma theta 1. Let us take a particle Q which is at an angle of theta 2. So this is A comma theta 2. Okay. So only theta is determining the position of particle. So theta is our generalized coordinate. Generalized coordinate. Okay. So we have a particle moving on circumference of a circle. Okay. So इसका क्या आंसर हो जाएगा? This is theta. Theta is the generalized coordinate. And number of generalized coordinate is 1. So the degree of freedom will also be 1. Okay. तो जो पार्टिकल का मोशन हो रहा है वो सिर्फ थीटा में चेंज होने की वजह से हो रहा है. ओके, सो कितने तरीके से पार्टिकल की पोजीशन चेंज हो रही है. ए इज ऑलरेडी कांस्टेंट, सो थीटा में चेंज की वजह से. ओके, चेंज इन थीटा इज थीटा 1 टू थीटा 2. सिर्फ थीटा में चेंज की वजह से पार्टिकल की पोजीशन चेंज हो रही है. सो कितने तरीके से चेंज हो रहा है? ओनली वन. There is no change in the value of a, so the degree of freedom is 1 here, and the degree of freedom is equal to number of generalized coordinate. So the number of generalized coordinate is 1, so degree of freedom is 1. So we have the generalized coordinate as theta and 1 is the degree of freedom. Okay, so let us discuss example 2. 5 particles moving in a plane. Let us draw a plane here. Okay, so this is x, this is y, and this is z. So let us take 5 particles. Okay, so we have 5 particles like this: particle 1, particle 2, particle 3, particle 4, and particle 5. So we have the 5 particle as 1, 2, 3, 4, and 5. Okay, particle moving in a plane. So how we can find the number of generalized coordinate? So we have number of generalized coordinate और डिग्री ऑफ फ्रीडम. डिग्री ऑफ फ्रीडम कैसे निकालते हैं? फॉर 2D प्लेन इट इज 2n माइनस के, एंड फॉर 3D प्लेन इट इज 3n माइनस के. Okay, so here number of, so this is 2D plane, so we have this formula will be applicable. So the number of generalized coordinate, number of generalized coordinate. Okay, so in 2D plane, 2D plane में क्या हो जाएगा? 2n माइनस के, तो 2 into number of particle is 5 and constraint here is 0. कोई भी constraint नहीं है, तो minus 0 is equal to 10. Okay, so here the generalized coordinates are number of generalized coordinate. So particle moving on circumference of a circle. Okay, so इसका क्या हो जाएगा? Z तो 0 हो जाएगा because it is in xy plane. So इसका coordinate क्या होगा? x1 y1, इसका x2 y2, x3 y3 और x4 y4, x5 y5. Okay, so these are the generalized coordinates. The total number of generalized coordinate is 10. So this is x1 y1 से लेके x5 y5, x5 y5. ओके, एंड नंबर ऑफ जनरलाइज्ड कोऑर्डिनेट 10 हो गया, तो डिग्री ऑफ फ्रीडम भी 10 हो जाएगा. डिग्री ऑफ फ्रीडम. ओके, सो सेकंड का आंसर क्या हो जाएगा? दिस इज x1 y1, x2 y2, x3 y3, x4 y4 एंड x5 y5 आर द जनरलाइज्ड कोऑर्डिनेट एंड डिग्री ऑफ फ्रीडम इज 10. So let us discuss question number 3. Two particles connected by a rigid rod moving freely in a plane. Okay, and this is 3D space. Okay, so two cases are there. First in case of a plane and second in case of a 3D plane. We have two particles connected by a rigid rod. So this is particle 1 and this is particle 2. And both are connected with each other by a rigid rod. Okay. So this is connected by a rigid rod. Okay. So we have this is case of a plane. Okay, so in the first case we have to find the in a plane. So the number of generalized coordinate in 2D plane is 2n minus k. Okay, and constraint here is 1 here. K is equal to 1 because distance between these particle is fixed. So the number of particle is 2. So 2 into 2 minus k is equal to 1 here. So this is 3. Okay. So we have the coordinate as let us take this as x1 and this is y1 and this is x2 and y2. Okay, so in question, two particles connected by a rigid rod moving freely in a plane. Okay, so we have the distance between these two particles is fixed. So the distance between these two particles will be let us take this as c. Constant, it is equal to constant. So the distance between these two particles is x2 minus x1 whole square plus y2 minus y1 whole square ka under root. This is fixed, this is c. Okay, and we have the coordinates of particle as x1 y1 and x2 y2. Okay, so this will reduce the number of generalized coordinates to by 1. So this is so number of generalized coordinates are 4 here and constraint is 1 here. So this will reduced by 1. So this is 3. Okay. So the degree of freedom will be degree of freedom is 3 here. Okay, so this, due to presence of this constraint, the number of generalized coordinate got reduced from 4 to 3. Okay, let us discuss question number 4. Two particle system connected with two particles. Second case is of a 3D space. So let us find this in 3D space. So here it will be one more coordinate will be added here. This is x2, y2 and z2. This is x1, y1 and z1. So this will be 3n minus k. Okay, so this will be 3 into 2 minus, the constant here is 1. So this will be 6 minus 1 is equal to 5. Okay, so 3n minus k is the number of generalized coordinates. So the degree of freedom will be 5 here. Degree of freedom is equal to 5 and number of generalized coordinate is 5 here. Three particle system connected with each other with one particle fixed. How we can find this? Three particle system connected with each other. Three particle system connected with each other with one particle as fixed. So let us fix this particle. So this particle is fixed. Okay, this particle is fixed. Okay, so we have 3 points 1, 2 and 3. Okay, connected with each other are one particle fixed. Okay, so let us take this as a case of a 3D plane. Okay, 3 dimension. So we have the number of generalized coordinate as 3n minus k. Okay, so we have k is equal to 3 here. First constraint is here, second is here, and third one. This is the third one. So we have k is equal to 3 here. So the number of generalized coordinate is equal to 3 times of the number of particle is 3 minus constant is 3 here. So this is 6. So in this question number 5 we have the degree of freedom as 6. Degree of freedom is equal to 6. A bob of a simple pendulum oscillating in a plane. How we can find this? Let us take a simple pendulum. This is a pendulum and we have the axis like this. This is the axis of the pendulum. Okay, so this is, let us consider L is the length of the pendulum. Okay. Okay, so the L is fixed here. Okay, so let us take the position of particle as theta. Okay, at theta, so here only theta will determine the position of particle. So since it is moving only in this 2D plane, okay, like this. So we have the number of generalized coordinate. Generalized coordinate is equal to 2n minus k. And what is the constraint here? L is fixed here. And we have the particle as 1. So 2 into 1, single particle is there, minus constraint is 1. So this is equal to 1. So the number of generalized coordinate is 1 and that generalized coordinate is theta. On changing the value of theta, the position of particle is getting changed. Okay, so this is theta 1 and this is theta 2. Okay, if we change the theta further, we will get the new position of the particle, theta 3. Okay, so this is further getting changed on changing the value of theta. On changing the value of theta, the position of particle is getting changed. So theta is the generalized coordinate here. Theta is generalized coordinate. And in how many ways the position of particle is getting changed? On changing the value of theta, the position of particle is getting changed. So the single parameter is theta. So the degree of freedom will be 1 here. Degree of freedom is equal to 1. That is equal to number of generalized coordinate. So the generalized coordinate is theta and degree of freedom is 1 here. Bob of a conical pendulum. Let us draw a conical pendulum. Okay, so in simple pendulum, the particle is moving like this in 2D plane. Okay, so on changing the value of theta, the position of particle is getting changed. But in case of a conical pendulum, it is moving like this. It is moving in a 3D space. Okay, and the value of phi is constant here. Okay, so only change is in the r and z value. Okay, so let us show this. So let us draw a conical pendulum. This is the axis. Okay. And this value of phi is constant here. Phi is constant here. Okay. So let us take few position of the particle. This is the position of particle. Let us take this as point P, this as Q, and this as R. Okay. And let us take this as a reference point. Okay. So when the particle is at point P, it will make a circle of radius. Let us say it will make a circle of radius R1. Okay. It will make a circle of radius R1. When it is at Q, it will make a circle of radius R2. When it is at point R, it is making a circle of radius R3. Okay. So when the position of particle is getting changed from P to Q to R, the radius is getting changed from R1, R2 and R3. Also, its distance from this x-axis. Let us take this as x-axis. So this is getting changed. This is, let us take this as Z1. Distance of this point P from x-axis. This is the distance of this point Q from x-axis is Z2. This is Z3. This is distance of point R from x-axis. Okay, so when the position of particle is getting changed from P to Q to R, so radius is getting changed from R1, R2 and R3, R1 to R2, R2 to R3, and the distance of this point P from x-axis is getting changed from Z1, Z2 and Z3. So the only change is in the R value and Z value, and because phi is only constant, so the phi is constant, the only change is in the R and Z value. Okay, so our generalized coordinates are R and Z. Okay, so when we move this particle from P to Q, so radius is getting changed from R1 to R2, and the distance of this point P from x-axis is getting changed from Z1 to Z2. The only change is in R and Z value. There is no change in value of phi. So the generalized coordinates are R and Z here. So in the bob of a conical pendulum, we have the value as R and Z are the generalized coordinate, and number of generalized coordinate is 2 here. So the degree of freedom will be 2 here. Okay. So R and Z are the generalized coordinate and degree of freedom is 2. In example number 8, a particle moving on surface of a sphere of radius R. Okay. So how we can represent a point in the space in spherical coordinate? Okay. So let us take this as this as x, y and z. Okay. So let us take a point P here. Okay. Okay, we can represent this point as r, theta and phi. Okay. So this is point O. So this OP is R. Distance of point P from origin is R. And this the angle that OP makes with Z is theta. Okay. So let us drop a perpendicular from P to xy plane. Okay. So let us name this point as N. Okay. So the angle that ON makes with the x-axis is phi. Okay. So we have the spherical coordinates as R, theta and phi. Okay. So R is fixed here. R is fixed here. Okay. So for determining the position of the particle, we need only theta and phi. So theta and phi are our generalized coordinate. So here theta and phi are our generalized coordinate. Okay. So suppose this point is R1, R is fixed. So suppose this point is R, theta 1 and phi 1. Okay, at point P. So let us suppose the position of this particle got changed to Q. Let us take this as new position. So this is R2, R is fixed here. So R, theta 2 and phi 2. This is new position. Okay, so from point P to Q, on change in the position of particle from P to Q, only theta and phi is getting changed. Only theta and phi are getting changed. Okay, so theta and phi are our the generalized coordinates. Okay, theta and phi are our generalized coordinates. So what will be the degree of freedom? So the number of generalized coordinates are 2 here. So number of generalized coordinate is equal to 2 here. So the degree of freedom will be is equal to here. So the number of generalized coordinate is equal to degree of freedom. So in this particular case, a particle moving on surface of a sphere, so the degree of freedom is 2 here. Okay, in how many ways the position of particle is getting changed? In 2 ways. On changing the value of theta and on changing the value of phi, the position of particle is getting changed. Suppose the particle is point Q, so this will be equal to r theta 1 and phi 1. Okay, suppose it is at r, point r, so the coordinate will be r theta 2 and phi 2. So only change is in the value of theta and phi. So only theta and phi are getting changed. Theta and phi are getting changed. Theta and phi are getting changed. So the theta and phi are our generalized coordinates. And in how many ways the position of particle is getting changed? So on changing the value of theta and on changing the value of phi. So in 2 ways the position of particle is getting changed. So the degree of freedom is 2 here. Okay. Now let us discuss question number 9. A particle moving on surface of a cylinder of radius r. So let us go back to a cylindrical coordinate system. So let us take our axis like this. So how we can represent a point in the cylindrical coordinate system. Okay. Let us take a point P. Let us drop the perpendicular on xy plane. So this is our x and this is our y. Okay. So we have the radius of cylinder as r. Okay. So let us drop a perpendicular from point P to xy plane. So this is point N. So the angle that ON makes with x-axis is theta. So this point is r theta n, and this Pn value is z, r theta and z. So we have the radius of cylinder is fixed here. So the only change is in the value of theta and z when the position of particle is getting changed. Suppose the particle is at here only. Okay. So particle is at point Q. Okay. And radius is fixed. So change will be in theta value and z value. Okay. So the only change is in theta and z value. So the theta and z are the generalized coordinate and the degree of freedom will be 2, because the position of particle is getting changed on changing the value of theta and z. On changing the value of theta and z, the position of particle is getting changed from P to Q and r is constant here. So the generalized coordinates are theta and z. A rigid body in motion in 3D plane. How we can find this? So let us take a rigid body. Okay. And let us take point P, Q and R. Okay, so let us name this as x1, y1, z1, x2, y2, z2, x3, y3 and z3. Okay, so we have taken a rigid body and we have taken point. Okay, so the distance between two particles, what is the property of rigid body? So distance between two particular point is always constant. Let us take the distance between PQ as C1, QR as C2 and PR as C3. So we have the distance PQ as x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Okay, under root is equal to C1. What is C2? QR. So this is x3 minus x2 whole square plus y3 minus y2 whole square plus z3 minus z2 whole square under root is equal to C2. and we have C3 as PR. So we have this as x3 minus x1 whole square plus y3 minus y1 whole square plus z3 minus z1 whole square under root. This is equal to C3. Okay, so we have three constants here. So k is equal to 3 here. So how we can find the degree of freedom? So we have the formula in 3D space as 3n minus k. So we have the number of points as 3. So 3 into 3 minus number of constant is 3 here. So this is equal to 9 minus 3 is equal to 6. Okay, so we have the degree of freedom as 6. So degree of freedom is 6 here in case of a rigid body in motion in 3D plane. Okay, so the degree of freedom is 6 here, means 3 are due to the translation motion plus and 3 are due to the rotational motion. So the degree of freedom of a rigid body is due to translation motion and second one is due to rotational motion. Okay, so now we have particle moving on a parabola. So let us draw a parabola. Particle moving on a parabola. So let us draw a parabola like this. Okay, so let us name this the equation as y square is equal to 4ax. Okay, so in terms of parametric form, in terms of Cartesian form, we can take the coordinate as x and y, and in parametric form, we have 80 and 80 square and 280. So we have any random point as 80 square and 280. Okay, where t is parameter here. Okay, so only t is determining the position of the particle because a is fixed here. A is the focus, a comma 0. So if we know the value of t, we can determine the position of particle. Okay, so the t is generalized coordinate. So t is generalized coordinate and degree of freedom is equal to number of generalized coordinate, that is 1. Okay, on changing the value of t, the position of particle will get changed. Okay, on suppose this point is P and we have the point, let us take this let us take the parameter as t1 here. So we have a t1 square and 2a t1. At this particular point, let us take this as q. So a t2 square or 2a t2. Okay, so on changing the value of t, the position of particle is getting changed from P to Q. Okay, so the t is generalized coordinate and number of generalized coordinate is 1. So the degree of freedom will be 1 only. Particle moving on ellipse. So how we can find the generalized coordinates? So okay, so this is our coordinate axis. Okay, so we have the ellipse like this. Okay, so we have the equation of ellipse as x square upon a square plus y square upon b square is equal to 1. Okay, so let us take this point as a comma 0 and this as minus a comma 0. This as 0 comma b and this as 0 comma minus b. Okay, so we have the equation of ellipse as this. So in terms of polar coordinate, we can represent any point. Let us take 2 points. Okay, so this as p and this as q. Okay, so in terms of polar coordinate, we can represent the point as a cos theta and b sin theta. Okay, obviously this point will satisfy this particular equation. So let us take the coordinate at point P as a cos theta 1 and b sin theta 1. Okay, and here we have at point Q a cos theta 2 and b sin theta 2. Okay, so on changing the value of theta, the position of particle got changed from P to Q. So theta is our generalized coordinate, and degree of freedom. So in how many ways the position of particle is getting changed? So in the on changing the value of theta, the position of particle is getting changed. So in one particular way, the position of particle is getting changed. So the degree of freedom will be 1. Okay, and this is equal to number of generalized coordinates. So the theta is our generalized coordinate and degree of freedom is 1. Okay, so we have discussed in detail about the generalized coordinate and degree of freedom. Okay, thank you.